All right, so please let me know. Can you see my screen?
Yes,
Yes,
ma'am.
ma'am.
All right, so on what we did last week, do we have any questions or we are good to go? Probably you solved the question or something, and then we need to just do a little review. Is there any?
Ma, yes, ma. Ma, I thought that you said you help us confirm if disease free we also involve recovery, being free
Recovered, yes.
and recovered,
Yes.
yes. So recovered and vaccinated. I be vaccine.
Yes. Yes, I did. So it actually depends on the assumptions of the model, like I said. So if we have an idea of what the population looks like before, and then they told us that some of the population, even before the start, had been infected, even without no new infection, definitely there will be the recovered class. So it's actually two ways, both ways works. It just depends on the assumptions of the model, depends on the assumptions of the model. So we could have, since there is no infection, there won't be the high class, there won't be the R class, and obviously no V class also. But if the population, I mean, but for your own this thing, since they said no infection, we are just going to go with no vaccination and no recovered class, basically. So all we just have is the susceptible. And if you just want to be on the safer side, you can still have the recovered class. It all depends on the assumptions. The issue I'm having is that no assumptions were stated for the model. So that's one of the issues we have. No assumptions were stated. The assumptions are supposed to be the guide that will tell us which one we are to go for. So the recovered class is actually very, very tactical. It could be confusing. So remember, I said at the start of the population, there could be some infected people already. Basically, you want to model. So if the question is no new infection, we can say, okay, some people might have been infected before we started modeling. Yes, some people, I mean, it's rare to find a population that is disease free. Is very, very rare. So when we want to start, it is possible that some people have been infected even before we started modeling, but we might not have new infections. In that case, there will be a recovered class because the people you met infected will have to recover even without treatment or without they either they recover or they die basically. So, but in the case of no infection, I mean the question is there was no infection, so we are assuming that when they got to the population nobody was infected. So if I want us to go with a more general case, it is possible that they got to the population and they met people infected which would be recovered. So in that case you are saying no new infection, but some people must have been infected before we got there to start modeling. So to be on the safer side, I would vote 70% going for adding recovered class, basically. Adding recovered class. Better to add it. And if it's not needed, they will mark your susceptible. But if it is, then because 6 marks, the issue I'm having again is that question is 6 marks. That 6 marks is not just leaving my head. So I would advise that we had the recovered class. And if um there is not supposed to be a recovered class, then we are still good to go basically. But just write S and R. We are very sure. No I, no V. But that R It wants to be confusing us. So just to be on the safer side, I mean, more advanced models, I'm the one that will define my assumptions. So if I say there is infected people already, they will be recovered fast. And if I say I meant the population clean, but in another sense of it, before we even decided to model, that means we got an insight that there was infection. Remember, no disease free is just like a subset. It's just like, okay, let's assume that there was no infection. In the real sense of it, before we decided to model a particular population, it is because there's an infection. So I would say go with adding the recovered class. It puts you on the safer side, basically. So let's add R to our S, but I and V is 0. So I hope we understand that a little bit.
Yes, ma. Thank you, ma.
All right, so let's just take it a step further. Now, so this class is a little bit mathematical. I mean, calculation, yes, it's a little bit, and the calculation is not a pressing calculator, but I really hope so. If there's any line or any step, this one just call me back so that it will be easier for us to track where the problem is, instead of you waiting for me to finish solving and then we now have to start looking for, okay, from where did you not understand. But I'll take it slow, and I hope you get it line by line. So equilibrium point, other names, steady state, critical point. Now the English is already giving us an insight to what an equilibrium point means. But for a better definition, an equilibrium point, okay, let me define equilibrium. When do we say something is in equilibrium? So it refers to a state where nothing is changing. That's just it. From that word steady, nothing is changing. The variables, they are not changing unless we decide to change them. But naturally occurring, what I have, it is in a state of nothing do me. I'm just there, very, very steady. So it could, if I want to translate it to modeling now, I can say that number of infection did not change. Day 1, 10 people were infected. Day 2, 10 people are still infected. Nobody left, nobody was added. Day 3, still 10 people. Day 4, 10 people. So at that point, we say it's in equilibrium. No addition, no subtraction. Nothing is changing, basically. So when they now say equilibrium points, so at that point, they are narrowing it down. It's no longer everything. It's no longer at all points. It's no longer at all time. So when they say equilibrium point now, we are already sticking to a particular value, a particular point in time. So I say at this particular T, the system is in a state of equilibrium, or at this particular value of S, of my S class, or at this particular value of my I class, this system is going to be in equilibrium. So an equilibrium point is just a particular value where the system is not changing. So it could change anywhere else. It could change at any other point, but at that very point, it does not change. Okay, so let's see what we have. So basically, mathematically, we have it here on the slide. Your dH dt is equals to your dI dt is equals to dR dt is equals to 0. Nothing is changing. It's just like you're saying it is equals to nothing. And nothing in math is 0. Now, there are now some subclasses of equilibrium points. So the trivial equilibrium point, that is when S is equals to I is 0. Now, note, there's a difference between the S dt is 0 and S is equals to I is equals to 0. Let's be differentiating. S is the class. ds dt is the rate at which the class is changing. So when they say equilibrium, that means the all that equations we generated from our model diagram, they are all equals to 0. But now, when we now want to do the subclasses, when they say trivial equilibrium point, that means the class, not the derivative now, the class of S and I is equal to 0. I mean, we are still going to do the mathematics. This is just the brush through because it's definitions and you might be asked to define it or explain it in your question. So disease-free. Now, remember, we've already defined what disease-free means. Disease-free means no infection. So that's already giving you an insight. When they say disease-free equilibrium, that means I is 0. S is not 0. But remember, because there's equilibrium, it means that all the derivatives are equal to 0. That one is constant K. All derivatives are equal to 0. But now, when I'm talking about the subclasses, when it's trivial, it means both S and I is 0. Then when it's a disease-free equilibrium, it means that S is not 0, but I is 0. Endemic equilibrium, it means that the disease persists. So it's just that the infection, there's still a control. Basically, there are so many definitions: endemic, pandemic. I mean, if nobody knows the meaning of pandemic, we know it's because of what happened in 2020. So endemic, there is still infection, but it is controlled. It happens at a steady state over time. Remember, disease-free, no infection at all. But in endemic, there is infection, but the infection is happening at a constant level. So maybe as they are recovering, those ones, they say, 10 people are infected, though. Day 2, and I say, 15 people are infected. And I say, what happened? 5 people out of the 10 people of yesterday got recovered, but 10 people added to the 5 remaining. That's why. So it is increasing at a steady state. Some people are moving out, some people are coming in. So S is not 0, I is not 0. But it has not gotten to the stage where we declare it a pandemic and say, the way, because if it is day 1, 10, and by day 200 has caught it, then there's a need. So endemic is still controlled, but there is still infection, just that it is happening over a steady state. Okay, so these definitions would help us when we get to the calculation part. Now, when is an equilibrium point said to be stable? So this will lead us to stability. Stability generally is that when I just try to touch the system, it moves, but it returns back to where it is coming from. That system is said to be stable when, if I slightly disturb that system, maybe just change I or change S, the system returns back to its original state. So an equilibrium point now is considered stable if the system always returns to it after small disturbances or perturbation. So it's an equilibrium point, basically. It's an equilibrium point. That means that it is steady. It does not change. But if I decide to tweak a little bit, then it returns back. It moves, but it returns back. Something just balances out again, and then I find out that it's back to the equilibrium point. So when it is unstable, it means that if you should disturb it small like this, piam, it just moves. Like the change is sporadic, and you're like, what happened now? Just because we introduced a new treatment, and even those that have recovered, ma'am, they are back to infectious class. So that's just the definition of being unstable. So now let's move to the calculation part. I would have to use my pen here. Yes, because it's necessary. So we did a model diagram last week. This particular one, I think this is the one we are using. So, okay, this one, yes, is the one. Yes. This particular one. So I will just put it down here because we would have to refer back and I will not want to be going and coming. So S, I, and R. You will see that all these things you have been talking about is S and R, I that is mostly being affected because R depends on what happens in S and I. If you look at what will I call it? If you look at the equation for R, it is dependent. This B is just debt. This particular one is debt. The main cocoa, they are coming from the infected class. So two major classes is the S class and the high class. So these equations will be needing it, the SDT and the high DT. And this equation is the one with the demographic effect. That is, there is birth, there is death, but it's a closed population. Basically, the number of births is equal to the number of deaths. That's why I still have B here and I have B here. One is birth, one is death, but they are the same thing. So we have a closed population and we have three classes, S, high, and R. And this is, so let's just move to where we can. So I'll just bring it here. Okay, they're using it for us. So remember, this guy, this first one is our DSDT. This first one is the DSDT. And this second one is the high DT. The second one is the high DT. Okay, they had equals to here. So they didn't just set it to 0. They set it to 0 because we said the equilibrium points. You see, this one is not a subclass. Generally, equilibrium point is where your derivatives are equal to 0. So this is our starting point. The SDT is equals to 0. The high DT is equals to 0. Now, I think we mentioned just 4: equilibrium point, trivial, disease-free, and endemic. So we'll be doing the 4. So this is the first one. Generally, the equilibrium point is where the derivative is equals to 0. Now, the trivial equilibrium point, trivial, is where S and high is 0. So this equation star, that's our model equation. For the other three subtypes, this is the equation we'll be coming back to. So when they say S is 0, I is 0, I will come back to this equation. Anywhere I see I, 0, S, 0, S, 0. So you will find out that what am I left with? In the first equation, the SDT, I'm left with B is equals to 0. Let's go again. S0, I0, this 0, this 0. Every other thing is 0.
Ma,
Okay, somebody is trying to talk.
yes,
Yes.
ma, but I thought you said that at the trivial equilibrium point, the S is not 0, but I is equal to 0.
No, that's trivial. Let's go back to our definition. It's 4. The first one is what's this guy? The first one is trivial. S and high is 0. The second one is disease-free. That's where S is not 0 and I is 0. Then the last one is endemic. Both S and I are not 0. Did you get that?
Yes,
So
yes.
for okay, trivial, both of them are 0. Both of them are 0. So that means that the equilibrium point epsilon naught is 0, 0. S is not 0 and I is 0. Then the last one is endemic. Both S. So both S and high, they are 0 here. So our equilibrium point is 0, 0. Remember, in fact, we don't even have to disturb ourselves. The general form of this guy is s, I. Remember, if you look at the definition, so this is the trivial, this is the general distance for the equilibrium point. So when both s and I, when they are both 0, then it means that that's trivial. When s is not 0 but I is 0, that's disease free. When both of them are not equal to 0, that is, what's that last one? Endemic. Yeah, that's endemic. Okay, so
Ma, please,
that's
can you take
trivial.
it
So
again?
both of them are 0. We don't have anything to calculate here. Both of them are 0. Now let's go to disease free.
Ma?
Okay. The equilibrium points we are finding, I'll take it again. So the equilibrium points, generally, there are 4 distinct. One is like equilibrium points is at the top of my diagram. Let me just call it EP. So this is equilibrium point. It now has 3. I mean, it could be more, but for this study, we have 3. First one, trivial equilibrium point. You will see that all of them still have equilibrium point attached to them. So trivial equilibrium point, disease-free equilibrium point, and endemic equilibrium point. So let's establish now. So we have 3 subclasses of the equilibrium point. Now, you see at this very, very top here, the father of them all is where this guy is happening. The derivatives are 0. The derivatives are 0. Now, I will call it trivial equilibrium point. If I find my S is 0. I find my I is also 0. So once both S and I, remember I already told you the difference. S is different from S prime. S prime is the h dt. So when I say S is 0, S can be 0 and the h dt is not 0. So let's not get confused with S and then the derivative. Equilibrium point, generally, the derivatives. So that means that in the 3 classes, the derivatives are equal to 0. We have established that. But when they now say trivial equilibrium point, at trivial, both S, the classes now, they are 0. What it simply means, if I want to translate it to something practical, what's happening in the population, there is nothing, no susceptible class, no infectious class, definitely no recovered class. Nothing is happening. It's like we're just saying that we have nothing at the very start. Like that's the start of my modeling. No susceptible, no infectious class. So that's when we call it trivial. So at this point now, when they say the equilibrium point, it's a double, the bracket, the first thing in the bracket is your S, the second thing is your I. So because we've already said at trivial point, S is 0, I is 0. So my equilibrium point is 0, 0. I really do not even have to go through this because everything will cancel out. Immediately you put S0, I is 0. I mean, B is just birth rate. So it means birth rate is also 0. You see, nothing is happening in the population. Nothing. So that's the trivial equilibrium. That's why the word trivial is there. That's like nothing is happening in the population. So by the time we now move to disease free, oh, I hope it's not network. Can you see my screen?
No,
Yes,
ma.
ma.
Hey.
Please tell me when you can see my screen.
Is it network? Okay, I'm going to leave and join again. Esther, can you see the screen? Okay, I'm seeing the screen now. Thank you. Ma'am, we can see your screen now.
So can you see the screen now?
Yes, ma'am.
Okay, okay. All right. So at trivial, there's even nothing to calculate. Nothing is happening. Everything is zero. Okay. Yeah. So at have I, can you hear me?
Yes, ma'am.
Okay.
Yes, ma.
So at trivial equilibrium points, okay. So at trivial equilibrium point, nothing is happening. Trivial. I mean, from the English word trivial, nothing is happening. S is zero, I is zero. This one does not even need any calculation. It follows automatically, basically. So can we move to disease free now? Okay. So now for disease free, okay, let me not. So for disease free, we said S is not zero, but I is zero. So this is what will happen. I don't want to delete everything, but it seems I have to. Okay. So for disease free, it is only I that is zero. So this is what I would do. I don't want to leave this equation page. So as I'm writing it. So I is zero. So this guy will leave. Remember, once anything multiplied by zero is zero. So once I is zero, eta is gone. So for the first one, for the one that belongs to S prime, I'm going to have B minus BS is equals to 0. Remember, the goal is to find what S is. So I'll move BS, it is negative. Once it crosses the equals to sign, it becomes positive. So I move this to the other side. Now B is common. Remember, B is a number. It's just like I say, divide both sides by 2 or divide both sides by 3. So B is a number. I can divide both sides by B. Please, I cannot divide both sides by S or by I. Those ones are not numbers. They are variables. So B, they are parameters, constants, values, numbers you can divide. But you see S and I, they are classes. So unless in special cases we'll get there basically. So I can't just cancel them out like that. So B will cancel B. Oh, sorry, what am I looking for? I'm looking for S, yes. So that means that my S is equals to 1. Is my calculation clear?
Yes, ma'am. Very clear.
Okay. So you will notice that the second class, even before you even say, remember we said there's no infection. So obviously nothing can come out of our second equation. But let's just try. I equals to 0. This we go. I equals to 0. Bye-bye. I equals to 0. Bye-bye. So you see, no infection. So the equilibrium point for disease-free, so the equilibrium point for disease-free will be 1,0. Remember, for this model that we have, they can change the model diagram. You just go and pick your model equations and set it to 0. Then you start working from there. So for the disease-free, for trivial, it is 0, 0. But for the disease free for this guy, it is 1, 0. So this is where this 1, 0 came out from. It is just by setting I to be equals to 0. So let's move. Endemic. This is the cocoa, because S is not 0 and I is not 0. So we have work to do here. Plenty of itself. So let me move to that screen. Trying to see if I can get somewhere to write. Okay. I hope this will be enough. If not, we'll manage it, sha. So our first equation, the one belonging to S, is B minus beta Si minus Bs is equals to 0. So I'll call this equation 1. So from here now, let me work with equation 1 here. Please follow me slowly. So remember, the goal is to look for S and I. Now this is the one for the S equation. So I'll try to make S the subject of the formula. Remember, none of it is equals to 0. So I'll move the negatives to one side and I will leave. Okay.
But I thought you said S is equal to 1 in disease free, that I is equal to 0.
Yes. I'm just using the slide for disease free because of space. I don't want to work here. This is the one for endemic. Yes, this is the one for endemic. There's no space here. And I don't want you to be using your left eye to be looking at this and then get confused. So that's why I want to use a slide that is clean. So that's where I saw space. Yes. So we are done with disease free. Disease free is 1, 0. I hope that's clear. Or do you want us to work side by side here? I don't want to confuse us. That's why. Or should I just put up a whiteboard? Would that be better?
Okay, whiteboard. Okay, I think whiteboard will be better.
Because I don't want to end up confusing us. Okay. Let me put up a whiteboard. Let me put up a whiteboard so that we can work with, because I don't want to confuse us, and it looks like I've ended up confusing us. Okay, so I'm still with us. So so sorry, please. A whiteboard decided to disappear here. I'm trying to navigate and I can't seem to see where it is or find it. So that I won't waste our time. I guess we just have to, but I don't want to confuse, especially those that will come back to watch the video, so that it won't be confusing. So that's why I actually want to.
Ma, this is fine. You can actually use this space. It's okay.
Okay, since whiteboard has decided to hide itself this evening. Okay, so let's continue. Uh, I don't have space again here. I would have just right. This is for endemic. So let me squeeze it in here. Endemic equation. Okay, um so I'm moving all the negatives to one side and I'm letting B stay on one side. So once it moves, it becomes positive. So B is equals to beta Si plus BS. I hope you're still following.
Yes, ma'am.
Okay, so my goal is to find S. So I'll make S the subject of formula here. So that means I'll bring it out. It is common. So this first term would remain beta I, and then the second term will remain just B.
Ma,
Okay,
please,
so now I need.
sorry, from the normal equation, and then okay, okay, that means we have two equations. Okay, we made S. Oh, you're trying to make S set of formula. Okay, ma, can continue. Sorry.
Yes. Okay, don't worry. We have to get it step by step like this. It's better. So make S the subject of formula, and I still have I here. Remember, we still have the I equation to work with. This equation 1 is the one for S prime is equals to 0. So even if I don't know what I is for now, I can still leave it this way. So to get S, I'm going to divide both sides by what is standing with my S. So this will be B over beta I plus B. So I'm going to divide both sides by what is standing with my S. I'm writing it out in full so that you will see how it is cancelling each other. So like this, all over beta I plus B. So these guys would leave. So this will cancel this. And then S is now standing alone. So S is equals to B over beta I plus B. So this is not the final answer, but we shall keep it somewhere. At least it has simplified the equation a little bit for us. Do we understand?
Okay, ma. So if they ask us to get the equilibrium, endemic equilibrium state, we start with this. We start like this. We get to this stage, and then we'll continue, right, ma?
Yes, yes. We'll start and then we'll continue. Now, let's see. And then the second one is also okay. I'm trying to find an alternative. Okay. So I'm still with us. So the second one now. Let's go and bring our equation. So I have to find an alternative for our whiteboard. Okay, so the equation belonging to I prime. So let me write this guy. Our S is B over beta I. So we've gotten S to be equals to B all over beta I plus B. So we are keeping it. Second one is quite longer, so that's why I want space, basically. Okay, so now the equation for I prime, the second one, we've worked with the second equation, the first one to get that S. So the second one we are working with now is beta Si minus gamma I. This guy looks like Y. Then minus Bi. So we set this guy to be equals to 0. Now, remember, we've already gotten what S is. So just follow me closely. I'm going to substitute. So this is what I will have now. I will substitute S. I will substitute it with what I got in the first equation, which is B over beta I plus B. Remember, I still have I. So it's just like I still have beta Si, but this is now what our S is. I've substituted. So the rest is still the same. Gamma I minus, so they are looking like J, minus beta I is equals to 0. I hope we understand this line.
Yes, ma.
Yes, ma'am.
Okay. So I don't want to work with the denominator, so I'll multiply each term by beta I plus B. The reason is because if, let's say I have one, let me say T over A, and I don't want the denominator, maybe this guy is in one equation, I'll just multiply everything by my denominator, so that the one that has the denominator gone is going to cancel out. The A will cancel the A. But because I can't just do it to this single term, it's like I'm being partial, so I'm going to do it across board. So the step now is multiply through by the denominator. I really want to take it line by line so that we can. So multiply through by the denominator. So this would help us eliminate the denominator. And that's going to be beta I plus B. So I'll be multiplying through by beta I plus B. So let's go. So I'm going to have beta I plus B. I want you to see how it cancels out. Because it is two terms, I'll keep it in bracket. Then what I have, I can just write beta I together because I can. Then times my S itself, which is B over beta I plus B. So you would see now that I can take care of the denominator, because this beta I plus B will cancel this beta I plus B. So my problem is solved. But I can't do it to this guy alone. I'm going to do it across board. So my gamma I would also multiply it by beta I plus B. Then finally, my B high also, I would multiply it by beta I plus B. So equals to 0. I hope we are still following. Equals to 0.
Yes, ma'am.
Are we still together?
Yes,
Okay.
ma'am.
So now I'll multiply through and open all the brackets. So first term here, I'm left with beta IB. Second, I will use gamma I to open beta I. So I is already occurring 2 times. So this guy is, because I have a mix of Greek and our normal English letters. Normally we are supposed to arrange alphabetically, basically, but beta has mixed with gamma, has mixed with I and B, and so that's, so you can write it, another person can write it as beta BI. Nobody's wrong, basically. So just stick with the arrangement that works for you. So the second term now will be beta I squared Y gamma. How to say I squared gamma. I multiply these two terms together. Gamma high times beta high. So I, that's I squared. I times I is I squared. So I'll do the same thing for the second term. Minus gamma high times B. So that will be minus B gamma I. Oh, I gamma. Even my own distance self is not consistent. Okay, so minus B gamma high. I will do the same thing for the last term. Open it up. BI times beta I. That will give me beta I squared B. Then the last one will be minus is now bi times b, which is b squared I equals to 0. Are we good to go?
Yes, ma'am, we are good to go. We understand it.
Okay, so now I'll try and bring those ones that look alike together. This one's now, I'm seeing I squared. This one now, beta I, bi. So let me rearrange. So I'm going to have beta I b minus beta I squared gamma minus beta I squared b. I mean, they have two things in common. Then the last two terms also, the ones remaining, minus beta gamma high minus beta squared I is equals to 0. So factorizing, so I'm going to have beta IB. So here now, I can bring beta I squared. I mean, it's common. So beta I squared should come out. So remember, I have to take note of this minus outside also. So this one will be gamma, then minus in minus, basically. It's then beta I squared, I'll be left with B. You can cross-check. Try to open that bracket out again. Are you going to get the previous step where we are coming from? So for here, beta I is common. So it will be BI is common. So that will be B high into bracket gamma. So gamma is left here. Then which one is left here? Minus in minus, that's positive again. So then I have 1B left because 1B is already outside, equals to 0. Are we clear with this line?
Yes, ma'am.
Okay, so next stop now. The real mathematical explanation is I is common. Factorize it out. That's what it means. I is common. Let me take you through that step. So it might look like what the person did is divide through by high, but that's how it looks outside. But this is what happened. I is here, I is here, high is here. Bring it out. So this will be I into brackets beta B minus beta I mean one high is coming outside, gamma plus B minus I is going. So this should be B into brackets gamma plus B is equals to 0. So now remember from basic elementary maths, if I say the product of two numbers is equals to 0, A times B is equals to 0. If I say A times B, I don't just want to manipulate it and just delete I. I want you to see why I is leaving. Because I did not divide through by high. When I was doing the slide, that's what it looks like. Divide through by high, but that's not what happened. if I say the product of two numbers, remember now, this one now, I can categorize I as a number and then my other bracket as another number. So it's like I times something is equals to 0. Basically, that's something. I can count it as a O. Just follow me. So in maths, when we say the product of two numbers is equals to 0, it means that one of the numbers is 0. Because two non-zero numbers cannot, the multiplication cannot give me 0. I cannot have 2 times 3 is equals to 0. So it is either A is 0, it is either it is 0 times 3 that gave me 0, or it is 2 times 0 that gave me 0. If anything is telling me that, oh, I multiply two numbers together and my answer is 0, what it means is that one of the numbers is 0. One of them is 0, or both of them, because 0 times 0 is also 0. So it's either one of them is 0 or two of them is 0. Now, if I want to take it back to my equation now, it's either I say I is 0 or that thing in my bracket is 0. But because I'm working with endemic, is it possible that my I is 0?
No, ma. Endemic I is not equal to 0.
Yes,
There's a
ma'am.
disease,
Okay.
so infection is there.
Exactly. So because under endemic, we already said I cannot be 0. So the next line here is that I know, I don't know any other thing, but I know that I cannot be 0. So what it means is that every other thing that I have in the bracket is the one that is 0. That is how I disappeared. We did not divide through. We did not just cut and say, cut I out of it because I is common. This is what happened. This is why I left. There's a reason, because I cannot be 0. Because I've already brought it out. You can see it that the product of I and something is 0. And because of our assumption, endemic, I cannot be 0. So if I is 0, I won't even get to this stage. So because I is not 0, it means that it is the whole of this thing in the brackets, beta B minus beta I into gamma plus B minus B gamma. It's like gamma plus B is common now. Gamma plus B is the one that is 0. So this is how I left. Because if you look at this guy now, you see this line, eh? Hey, Oluwa. It's a mathematical error. Divide through by height to get, I don't know who wrote it to. It could have been the lecturer, but mathematically, we don't divide through by variables. There's a reason why it is. So, I mean, to a non-mathematician, I is common. So, the easiest thing they can remember is to say, oh yeah, cut it, divide through. But mathematics, if you put this thing in front of my professor saying, this one line is an error. So high, we can't divide through by high. I just showed you how I left and we got to the next step. So I hope I did not confuse us.
No, not at all, ma. Thank you, ma.
All right. So let's move. So now I can now continue with the one that is 0. So if this guy is 0, I can try to collect like terms. See, I'm already seeing gamma plus B is common. Gamma plus B is common. Then beta B. So let me move my middle term. Actually, I'm looking for I. I'm looking for I. So the only one that has I left is this middle term. So that's why I want to move it. so that I'm going to have beta B minus B into brackets gamma plus B is equals to, so once I move it to the other side, that negative becomes positive. So I have beta high, then I have gamma plus B. Okay, so it's becoming clearer now. So to get my high, let me collapse the next step here. I'll just divide through by every other thing that is standing with I. So that will be beta into gamma plus B. So
Might be because you are
divide
making
both sides.
ma.
I'm with you.
Okay, I said when you finish telling us that I is not equal to
Please
0,
ask your question. Oh, is it because we are making what?
I think it's network that is making everything lag. When you said that I is not equal to 0, that is the other formula that is equal to 0. I lost track of what you did
Yes.
next. So from this other part, this second equation, please can you start from there? The next one that you
Okay. After
started after.
I is not equal to 0. Yes. So okay. Okay. So after I've already, because of my assumption, I cannot be 0. So I would have to move on with the second part being 0. So that's the one I will continue with, basically. So that is what eliminates I from that equation, because I cannot be 0. So we just leave it out. That's what eliminates I in the real sense of it. And we continue with the other part that is 0. So the other part that is 0, remember, I have S up here. What I'm looking for is high. I mean, there's no S in this equation set. So what I will try and make the subject of the formula is I. Now, if you look at these 3 terms, 1, 2, 3, the only one that has I is this middle term. So that's why I isolated it and I took it to the other side. So it became beta B minus B into bracket gamma plus B. This guy moved to the other side and became positive, is equals to beta high into brackets gamma plus B. So because I'm looking for high, I'm going to divide by every other thing standing with high. If you look at it, beta is a parameter, gamma is a parameter, B is a parameter. All of them are numbers. So that's why I'm dividing through. It's just like I'm saying divide through by 2 or divide through by 3. So if I'm dividing through by every other thing standing with I want to isolate I. So that's why I'm dividing both sides. So the step here is divide both sides by beta into brackets gamma plus B. So by the time I divide, you will see that I is standing alone now. So I is equals to beta B minus B into brackets gamma plus B all over beta into gamma plus B. So you will see now that everything I have here is just numbers. Beta is a number, B is a number, gamma is a number. So it's just, if they give me values for all these things now, I can compute what my high is. If they say take B to be 2, beta to be 3, gamma to be 1, and I'll have a number. So this is high. It was a long journey, but we got here. Now, remember I said we are not yet done with S, because S still has a variable in it. I mean, how can I say that they're asking me for a variable and I say A is equals to 2B? They say, do you want to confuse us? What is B? That's the reason, that's the meaning of this high that is here. So what we need is a value. What is S? So I must not be seeing another variable inside the answer. So that's why I will now bring S down here. That's okay, oh, S, you have helped us in getting I. And our S is B all over beta I plus B. So where I'm seeing that I will substitute my I inside so that I can get S also in terms of parameters. So another journey. Now this one is in the denominator, so we really have to be very careful because what is coming in is also a fraction. So I is all this guy. Let me substitute it. Let me divide this so that we don't mix it up. So let me bring it in. Beta B minus okay. I'm thinking of, should I open the B into brackets gamma plus B all over beta into gamma plus B. Remember, this is just beta I. So I'm still going to have plus B. So beta, we cancel beta. They are on the same side. It's just like I have 2 up, I have 2 down. They can cancel each other. So beta is in the numerator, beta is in the denominator. It's a number, it's a parameter. So I can cancel it out so that the next step now, I will try and find the LCM of my denominator because I need to simplify this fraction as simple as possible. Remember, beta is out of it now. So let me carry this guy. Let all of them at the denominator have a singular denominator. I mean, just follow. So this will be beta B. Let me put the denominator. So the denominator now is gamma plus B. So let everything be under this guy. So the one that has it initially, I have sorry, this should be beta B. So I can't erase now. So this is beta B minus B into brackets gamma plus B. Now remember, my last term, it does not have the denominator before. So if it has to have the denominator now, that means I'll multiply. If you remember our LCM rule. Yes. Now, I hope we are not confused at this stage.
No, ma. I think we can remember
Are we
that.
still together or our is already turning on its own?
No,
Do
we
you
are still
understand?
yeah.
Yes, ma'am.
So beta into that one.
Okay, now if you look at the second term and the third term, please, what is happening? Check the numerator of our denominator.
They will cancel out
What
each
is
other.
happening? Second term, exactly, because it's just they are the same thing, just that one is negative and one is positive. -2 + 2 is 0. -5 + 5 is 0. So when you have negative and positive of the same thing, they will give you 0. So those guys, they would leave, and then what we have is B over beta B all over gamma plus B. So it looks simpler now. It's looking simpler. So now, what we just have to do is just a simple mathematics that says if A divided by B over C, you see the denominator of the denominator, its place is up. A times C over
Wait,
B.
calculate. Okay, that
That's
side, this side. When I left with beta B. Oh yeah, yeah, yeah. Oh, but we understand.
okay. So this guy, so I'm just going to bring the denominator up. So this guy will be B into brackets gamma plus B all over beta B. And that is our, okay, B is common. B is common. B can leave now. So my final answer is S is equals to gamma plus B over beta. So you will see now that everything we have under S now, they are also parameters, no variables. So our equilibrium point S comma I is the endemic equilibrium point is equals to this guy comma this guy. This helps me so that I won't rewrite it again. So that's the last line of the question.
Okay, ma, that's true. That's true. That's true. We see it now.
So what they did is just rearrangements, and our what do I call it? Our answers are just what we have. So are we together? Is any
Yes, ma, we are
is
together.
anything
That's
looking
together, ma'am.
like okay? So you can see it's not difficult. It's just some mathematics up and down, and then we have the equilibrium states S comma I. So that's the last one. So when it's trivial 0 0, what's the next one? Disease free. When it is disease free, I is 0, S is not 0, you find S. Then when it is endemic, both of them are not 0. Okay, so I think the last question we left said estimate the disease free equilibrium for these models that we have. 10 marks. Oh, hey God. People just finish the question because they did not even ask for endemic. Endemic is the one that will stress you. Disease free, high is 0. It's just S that you will find.
Ma,
But
please,
now they said no, it's 2 models. Let's say 5 marks. And it's even simple because I think
can we do it? Can we do the model
can
diagram?
we what?
Can we do the model
Yes, so
diagram?
we will do it and you will be the one to do it. Yes, we will.
We'll try it and
Who
send
said
you
we should do the
our
model diagram again? Jesus
answers.
Christ of Nazareth.
No,
Okay.
no,
For the sake of
no,
those
no.
who asking for model diagram, let's even get the model diagram first so that we will not be working with. I think they asked us to remove.
I wanted to say model equation. It will be easy for us to get the model equation and then we'll go straight to the disease free
Yes, yes,
equilibrium.
yes. Hey God. I understood what you meant, and I ended up saying model diagram too. Okay, so I understood you meant model equation. So that's what I also want to do. That you will do the disease free by yourself, but let's start from the same point, which is the equation. So for this first one, we already did the last time, so it should not be a problem. Our S prime will be equals to, remember, it is in minus out. But if you remember, they said for each model, remove the demographic effect and present the updated model diagram for each figure. So that one, then the second one is now write out the model equation. So removing the demographic effect means that we are removing the births and the deaths. We are removing these guys. We are removing these guys, this guy, this guy, this guy. So your S prime is just equals to minus beta Si. Remember, there is nothing coming in again. So it's like 0 minus beta Si. And then our I prime will be equals to what comes in, which is beta Si, minus what goes out, which is alpha I minus Ri. Remember, there's no demographic, so there's no death. So that's for the first one. Then the second one, I think they are similar. It's just going to be minus beta Si, and then for the I prime, it will still be in minus out. Just that in this case now, we have only one out. So beta S high minus alpha high. So I've helped you. So everybody's starting from the same points now. Those are our equations. Remember, we don't need R because when we are talking of equilibrium points, we just need our S and our I. So for the two model equations, find the disease-free equilibrium point. So that's for us now.
Okay, ma, can we do it? Should we start? Hello, ma. Should we start doing it?
Yes, I'm with you.
Should we do it? Like, should we be talking and be solving it on our
Yes,
book?
so over to you. Yes, 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 yes.
Okay, let me try. Please, Esther, beg, make I try.
No wahala.
Okay, since you want
I
to,
will do,
you have the floor.
I will do for the first equation and then maybe someone else will do for the second equation.
We'll do for the second equation. Okay, so I don't know. Can you write from there? I don't think so. It's
I
going to
will,
be whiteboard now.
I thought I would use my mouth to talk.
Okay, no problem. No problem.
Okay,
No
ma'am.
problem. The goal is to get it done.
Okay. So for the first equation, for the first model diagram that we have, we already have our equation where the t is equal to minus beta Si, and then di dt is equal to minus beta Si minus gamma. Is this gamma now? Yes, gamma I minus R.
Okay.
Okay, so the disease-free equilibrium will be, disease-free equilibrium states that the susceptible are they're not equal to 0, that is they are 1. We have susceptible participants or group, but the infected group are not there. That's why it's disease free. So that is in
Yes.
S over dt will be equal to b minus beta s times 0. Okay, minus beta times 1. Okay, that's true. Times 1 times 0, which will give us 0
Okay.
eventually. Then the di over dt will be equal to minus beta times 1. S is 1. times 0 minus I is 0, so it's 0 there, minus I2 is 0, so it's 0 in the
Wait,
recovered
where
part.
did you see? Where did you see? Wait. You're already going zero for me. Where did you see S equals to 1?
Because it's a disease-free
Where
equilibrium.
did you?
You said that in disease-free
Eh,
equilibrium.
remember I said, come, wait.
Yes,
For
like,
disease, yes. See, for disease-free equilibrium, S is not 1, no. S is what you are looking for. The one we did here, we got S to be 1. See, it was our calculation. That said S is 1 because of the equation that we had. Because of the equation that we had. Your equation has changed. See, remember, look at S is still S here. The only thing they set to 0 is I. The only thing they set to 0 is I. So even though everything will still eventually give us 0, but in case of an equation that it will not, so that now your 1 will not go and cause problem. So S is what you are looking for. S is not 1. This one that we did, we solved the equation. We solved this particular model diagram. We solved this. Please mute your mic so that you can be clear. So it is this particular model diagram that we found its equilibrium points. So it's not general. It is this model diagram. This is the one that we found the equilibrium point that, okay, when it is trivial, it is 0, 0. When it is disease-free, it is 1, 0. When it is endemic, it is that thing that we got. So if they give you another model diagram, it's going to change. Remember I told you this is the equation we are working with for the example. But in the question now, they have changed the model diagram. In fact, this one has demographic effects. That one does not have. So S is not 1. So you're not going to write your final answer as S equals to 1, it is 1, 0. It is not for all. Your model diagram, which determines your model equations, determines what your S would be. So you can continue now. I think that has become easy.
Yes, thank you so much, ma, for the clarification.
So let's go.
So, ma, then
the where did I lose? Where did I just found out the network kicked me out. So where did the network, what was I saying?
No, we actually said thank you for clarifying it. Thank you for clarifying that S is not 1. So to
You
do
can
the disease,
continue now. You can. So you're right on that.
okay, disease-free equilibrium for the first equation, for the first model diagram, then the S, the T will be minus beta times S times 0, which will eventually give us 0 because 0 is multiplying everything there. Then the idea will now be minus beta times S times 0 minus gamma times 0 minus R times 0, which will still give us 0, ma. I don't know if I'm correct, ma.
Can I chip in, ma?
Yes, you are. Remember, I is 0. So definitely everything there will be 0. Okay, so who wants to say something?
I was thinking, how about to do it the way we did it like the previous time, where I is common
I'm
to all
listening.
of
I think
them.
somebody wanted to chip in something.
Yes, ma, I'm speaking. I don't know if my network is lagging or not. I said,
Okay, I think it's breaking. So let's go again.
okay. I said, can we do it the way we did it the last time? Since we are sorting for I, such that I is common to all of them. then it's going to be I into bracket beta S minus gamma minus R.
I didn't get that. Can we do what?
I said for the I over dt, that's I prime. Can we, since I is common to all of them, can we put I as the subject of the formula? So it's going to be I into brackets beta S minus gamma minus R.
I is 0.
Okay, ma.
Are we still doing the same question? There's no gamma here. What I have is beta, alpha, and R.
Oh,
So
sorry,
which one
alpha.
exactly are you referring to?
Alpha rather, sorry. It's the first
So
one
that
I'm
I
talking
can be
about.
on the same page with you.
I, should I repeat it? I said, can we do it like this? I prime is equal
Okay.
to I into brackets beta S minus alpha minus R is equal to 0. Can we do it that way?
Of course, you just factorize I out of the bracket. And then when you set it to 0, everything turns to 0.
Oh, it does not work like the previous one that you
Remember,
said
for
maybe we can
disease free,
remove.
yeah, in endemic, yeah, in endemic, I is not 0. But in disease free, I is automatically 0.
Okay,
That's the
okay, ma.
starting point. Once you get disease free means that so the whole of I prime has I in it, so everything is 0. So even if you bring out the I, everything will still go back to 0. So the disease free for this guy, disease free, disease free for this guy is actually 0,0. It coincides with the trivial because you to reason it, nobody is coming out, nobody is dying, and you said there's no infection. There won't be any susceptible class. There won't be any infectious class. Because it's even coming in. If you recall this one that we did, not even endemic, the one that we did here for the disease free, you will see that beta S still left. But what we had was that B, those ones that came in by birth, and this other B, those ones that died. So because there is no demographic, they are the ones that said we should remove the demographic effect. So assuming we didn't remove the demographic effect, we would have had something like, I think that was pi. We would have had something like pi minus beta Si minus mu s. So this guy would not have given us 0. Yes, he wouldn't have given us 0. We would have had something like pi over mu. But because they said we should remove the demographic effect, we have removed it. And they now said there's no infection. Everything is 0. So, I mean, your questions are actually very simple. So we've removed, if we did not remove the demographic effect, we would have gotten a value for S. But you see this I, till thy kingdom come, it will always be 0 because there's no infection. So what determines if you will have a value for S is actually this susceptible class. And now, the only thing in susceptible class is the people that are infected, that moved out. So, and there's no bed. So what do you want us to do? 0. So the disease-free equilibrium point is 0,0. And I think that's the same thing that will apply for the second one too. That's the, that's the same thing that will apply for the second one too. So it looks like they just want to test that you understand this thing. There's really nothing difficult to solve here. If they had asked for endemic, we would have been in for it, but they did not.
Ma, can we
So,
check
I
endemic?
mean, it's yeah, of course, that's
Okay.
actually what dropped in my mind. So that if you people go and see, estimate the endemic equilibrium, you know, go and say, the first question is this free? Oh,
Okay,
okay.
ma.
So, who will help us with the endemic now?
Let us. Esther, oh yeah, na alpha.
So,
Hey. Yeah, let's see.
okay. You can do it though.
Yes, I want
Let's
to
go
check
to
it out.
whiteboard so that yeah. We have this written down now, so I can let me see. I think I have another page here.
Is it going to be with without demographic effects too?
No, let's still work with no demographic effect. Yes, let's work with no demographic effect. So I'll write out the equations. S prime will still be minus beta Si. And oh wait, before we even move to endemic, let's assume that they did not ask you to remove the demographic effect. What would have been our S in that case? So I think we should solve that before we go to endemic. Yes, let's solve that before we go to endemic. So for the first one, S prime is if there is demographic, that will be pi minus
Minus ds
beta s
beta
I,
s.
yeah, so minus this guy s. Then our I prime would have been, what would that be? Beta si
Si minus mu pi
minus alpha I minus ri then minus mu high. So who is helping us? Let's say they did not ask us to remove the demographic effect. Of course, we know it's the first equation that you would set to 0 that will help you. So at equilibrium point, both of these guys, they're equal to 0. So, but we need to get what S is. So who is helping us?
I will help. I will help.
Oh yeah. So let's go.
Okay, so
So this is what we are solving now.
yes, ma'am. So for disease free equilibrium, S is not equal to 0 or I is equal to 0. And in this aspect, we have the demographic effects
Yes.
reflected in this equation. So what we do now
Uh-huh.
is the first one is pi minus beta times S times 0 minus mu. Is that not mu? Mu S. So our S prime will now be pi minus mu S. So our
Okay.
S will now be equal to, okay, so because we want to make S the subject of the formula, we take S to cross over the equal sign. So pi is equal
Okay.
to mu S. That is S is equal to, we'll divide both sides by
Okay.
mu. We'll divide both sides by mu. Then S is
Mm.
equal to pi over mu.
over
Yeah.
mu.
That's,
That's all.
that is
We
it.
did it.
So our disease-free equilibrium point in this case now will be equals to pi over mu. That will be pi over mu comma 0. So that's it. So in case they did not ask you to remove the demographic effect, you see now that it's not even 1. Why? Because they did not tell us that it is a closed population. So if they had said it's a closed population, that means my pi is mu. So pi over pi or mu over mu, any variable you want to, any parameter you want to keep. That's how we got that 1,0 that from where we were coming from in that example, because it was a closed population. Birth is equals to death. So this pi is our birth rate. This mu is our death rate. They did not say anything in the question that if they had told us it's a closed population, it will be pi over pi. So that will be 1,0. If it is an open population, that means it's not equal. Birth is not equal to death. This will be your answer. So it is not always 1, basically, so that you will not just go and assume that, okay, once I see disease free, I know it is 1,0. The model diagram, what is happening in that particular population, is what determines what exactly is happening. So I think the same thing will work for the second one. The same thing will work for this second one. If we decide to add the demographic effect, is also going to be pi over mean, because they have the same distance. So I will always give you 0. Everything 0, 0, 0. So I think I'll go with that. So let's now treat endemic. So endemic is the long journey guy. So let's treat, what if this guy, what if the question is saying find the endemic equilibrium points? What would we have gotten? So who is helping us? Our two equations. The first one is pi minus which one should we do first? Should we do when there's no demographic? Let's do when there's no demographic first, so that one will ginger us. Because if you go and start with when there's demographic, it's long journey. So this is minus beta si. I think it will still give us 0. This thing I'm looking at, but let's try. Okay, beta si minus alpha I minus ri. So who is helping us is equals to 0. So let's just try. No demographic effects, and they now said endemic. Who is helping?
Okay, ma, I want to try. Esther, you want to try?
Yes, for the endemic, S is going to be equal to 0 because it is minus beta si. There is no way we can even get it. If you are going to say we are
Yes.
dividing by beta I just to make S the subject of formula, it's still going to be 0 divided by beta I. So which is making it 0.
S is 0. So let's see. If we put S is 0 in the second equation, will it give us anything tangible? Remember, I is not 0.
Okay.
So if we substitute S to be equal to 0.
Yes.
It's two ways though. Okay, so let's go.
It will give us something tangible. So if you substitute beta si becomes 0, then we are left with alpha I minus ri. We can make I the subject of formula, I guess. Yes.
Okay, both of them actually carry the negative.
Yes, negative I into brackets alpha plus r is equal to 0.
Okay.
If we divide both sides by negative.
What is happening? Please do.
Are you? Yeah. Am I right? Actually,
I understand that the I. I understand that under S prime for endemic equilibrium without demographic effect is 0. That one is 0. I get it.
So, from here we try to get S, and we saw that it will be 0.
Yes. So what are we now doing next? Please, oh.
So in our second equation now, yeah, you can continue.
Okay, so we have beta si minus alpha I minus ri. Now, because of S, there is already 0 from the first equation. Our S is going to like make beta si make it 0. Then we are left with alpha I minus ri. Then we can make I the subject of formula if we want. So if we put it in a bracket, that's we have minus I into brackets alpha.
So do you understand? So what we try to do is that, okay, let's say from the first equation we got S to be 0.
Yes, ma'am. Good too, ma'am.
Mhm. Okay. So we see
It's still
you
zero.
see that we're back to where we started. It's still 0, 0. Because it's just, I mean, it's just real life. You said nobody came, nobody went out. And now let's see if, though, for this population now, what it means is that there was no infection. There was no infection in the population at the beginning. So, because it is possible that even though nobody came in and nobody stepped out, it is possible that at the very beginning, I mean, in much more complicated model diagrams, that is not just 3 terms. You can have as high as 6, 7 terms. So it is very much possible that nobody came in, nobody died, but still yet some people in the population has been infected. So, but for this case that we have now, it's very so in a nutshell, like they just want to, they just want to give you people 10 marks that, let's not stress. And you will be there thinking it's something hard. You say, hey, 10 marks, I will not do question 5. Oh, now just imagine ABC. We've done it, 20 marks. I mean, how many marks do somebody need to pass the exam that will now run from 120 mark question? So is it really not hard? But let's even say now that there is demographic effect, and they said we should find it. That's the highest thing they can ask. That's the most difficult one. So let's say there is demographic effect, and now they now ask us to find the endemic. Just the same way we find for the disease free. Let's try and see how complicated it can get.
Okay.
So now we have to introduce our demographic parameters back. So this would be,
Pi minus beta si minus
so the first
mu.
one, who is doing it for us? Or we are trying to put pen to paper.
Yes, ma'am. Can I do it? Plus, yes.
Okay.
Okay, so
Okay.
we are looking for the
Network
endemic.
Kolma.
Should I go on?
Yes, yes.
Of course, yes.
Yes, yes. So we are looking for the plus yes. We are looking for the endemic with demographic effects. So we have
Yes.
our normal equation will still be, that's the S prime will be pi minus beta Si minus mu S equal to 0. The I prime will now be beta Si minus alpha I minus Ri minus mu I
Yes.
0. So with the fact that we have a demographic effect, S and I, and is an endemic state, S and I, they are not equal to 0. So we have for S prime, we now have what is in pi minus beta times S times I minus mu times S equal to 0. So factorizing S out, which is common between the two the second and the third parameters in that equation, factorizing Si will have pi minus S into brackets beta I plus mu close bracket equal to 0. So making S the subject of the formula, we have S open brackets, beta I plus mu, close bracket, equal to pi. So S is equal to pi, dividing both sides by the coefficient of S. S will be equal to pi over beta I plus mu. Close and open your bracket.
Okay.
So that's for
Okay.
S.
Yes. So
It was
we've
fire.
been able to get S. So let's now move over to
We are done
I.
with
You still have I in S. So
we are
you're
done.
not done with
And
S.
now this is just S. Remember, S is not 0 and I is not 0.
What's your answer?
Yes, we want to go to the second equation for I.
Yes.
So the I equation will now be beta times
So
S.
the I equation is
Oh, is it not charging?
you're on track. Oh.
Okay, beta times S times I minus alpha times I minus R times I minus mu times I. So I equation will be equal to. Ma, am I supposed to substitute for S here? Times.
Yes.
Of course, that's the next thing now. That's remember you got in S.
Jesus. So beta times beta.
Yeah, also we substitute for S.
Yeah, so it will be beta times pi over beta I plus mu, close and open brackets, minus
Mhm.
bit alpha times I or alpha I minus Ri minus mu I. Voila, they buy.
Hmm.
Okay.
So what do we do now?
Okay. I is not equal to.
Beta and beta.
Okay. I don't know. Can beta and beta kill each other?
Denominator.
No.
Denominator.
No.
You multiply two by the denominator.
Denominator.
Okay, that's true.
We will multiply through by the denominator.
Okay. Times I. Okay, let's multiply two. If we multiply two by the
So once you
denominator,
multiply through, let's go.
we have beta times pi times I minus alpha I minus gamma Ri.
Alpha I open bracket.
Alpha I open brackets. Okay, that's true. Beta I
plus mu.
plus mu close brackets.
I'm still with you. Our denominator is beta I plus mu. Yes. Yes, we are on track now. You are looking at it, hey, this is getting harder.
The
It's not.
equation is getting longer.
It's
Yes,
getting longer.
it's getting longer, but not difficult. Yes, it's not difficult. It's just getting longer. So let's go.
I've lost my eye in the process.
Yeah. So what I'm just doing is multiply through. I didn't want to repeat the first time with the denominator. It has cancelled out basically. So that's why I'm left with beta, then I, then pi. Remember, that's the thing. That's what I have in my numerators. Beta, pi, pi. So the rest is just alpha high, Ri mu high. So I'm just multiplying each of them by that denominator. So you can continue now.
So the one that is common there that we should factorize out is beta I plus mu.
Open the brackets.
Are we going to open the brackets?
Beta I plus mu is what we use to multiply everything now. Yeah, so open the brackets. That's what will make you see clearly the ones that are familiar. And now, you want to factorize something that we just use to multiply everything.
Okay, so we have beta I minus gamma I beta
How
I.
funny.
alpha I
Okay.
square,
Mhm.
alpha I square beta
Mhm.
minus no alpha I square
Pressure.
beta minus
Minus
It's the same thing now.
Pressure,
Alpha I
T-well.
squared beta. Alpha beta I squared. It's the same thing.
alpha
Yeah.
I minus
R
R
square.
I square beta
Mhm.
Of
minus
course.
R I mu minus
Mm-hmm.
mu
Yes.
mu
I
I square beta minus
Mm-hmm.
yes.
minus mu square. No,
Yes.
mu square I.
I yes.
Voila, dey. What
Mhm.
is this?
Mm-hmm.
Mhm.
Thank you. Yeah, so you can see the I squared now. Let's bring the I squared together.
I
Okay, so
bring
beta pi I minus I square open brackets gen
Oh,
Yeah,
okay.
alpha beta
it's not
alpha
difficult.
minus alpha beta carry that first.
Is this guy?
They are put light now.
also
Minus alpha beta
Mhm. The
minus okay.
second one is this guy.
I'm not dey see your screen again. I can't see your screen again. No.
Are you using the screen to do this thing?
No. I won't do am now. I could beat you. Oh.
I think I'm done. I think I'm done.
If
I don't know.
I not done anything. If I not done, you know done. So
Ah, wow, lad.
alpha
Oh
beta.
yeah, let's help out. Let's help out. Oh, rubber hook.
Okay, is I that is common, is not I square that is common.
yeah.
It's I that is common. So this one will still carry I minus alpha mu minus it's plus oh. So that times plus and sign is minus
I've
plus
already underlined those ones that have I squared. So we have alpha beta here, R beta here. No, it's I squared though. I squared though. Eh? No, no,
yeah,
no, no, no.
like this
Those
one.
ones with singular high, I'm leaving them. Those ones with singular high, it's just the ones with I squared that I am picking now.
Okay. 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 I square. Well, let's pick I square people. Beta alpha beta minus I square. Alpha beta plus I beta
In fact, I'm even supposed to bring beta out.
mu.
It is beta I squared that is common. Help me now. Yes,
Yes,
it's
ma'am.
beta I squared that is common. So it will be alpha minus R minus um alpha minus R minus mu.
Okay. Mu,
Then
yes.
secondly, I will bring out mu I. If you look at the remaining three, they have mu I in common. So that I'll be left with alpha plus R plus mu, I think now, is equals to 0. So are we together on the same page now?
Yes.
We are not together, ma. Please wait for us, please. We are trying to figure it out.
Okay.
Okay.
Okay, let's figure it out
When you
together.
are done, tell
Beta
me your
pi
answer.
I, that one does not have problem. So
Why
the
is this?
ones with I squared, if you look at it, all of them have beta.
Yes.
So that's why I removed the beta self and I brought it out so that it will be beta I squared. So look at the first one I underlined. Beta I squared, I'm left with alpha. Beta I squared, I'm left with R. Beta I squared, I'm left with mu. Now look at the three other ones that are not underlined. Those ones have mu I in common. So bring mu high. It's just maybe the minus that can be confusing, but apart from that, there's nothing else. So mu high alpha is remaining here. Mu high r is remaining here. Mu I, no, this last one is mu squared I. So if mu I is out, then it should remain one mu inside, and we are good to go. So is it clear now?
It's clear. Oh, thank you, ma. But your
Ma,
sign in the other bracket, in the beta I bracket, is subtraction. It's supposed to be addition. So that when
square.
beta I
Okay, it's
squared,
supposed to be plus. Abi, this is alpha plus, yes, yes,
I want to confirm something. No. Have you gotten the
yes,
final
it is.
answer?
We've not we are just starting. So
Okay,
now
because
look at I. So you know how high we live now. I don't want to go through that long process. So I'm just going to let I live. Remember, I did not divide through by high. I factorize I
yes,
out, and because I cannot be zero, we can proceed from there, so that we would not be writing too much. So once I leaves,
sorry, ma, I did not get you, ma. Sorry, ma.
so I'm saying look at each term. Now we have just three terms: term 1, term 2, and then this is the third term. Now, if you look at each of the term, they have I in common. So I'm saying that factorize that I. So you have I times something is equals to 0. But because we know that our I cannot be 0, we will now work with that something that should be equals to 0. So that is the stage at which we are now. So it will be alpha plus r plus mu. I hope you got that part.
Yes, ma. Yes, ma.
Okay. So alpha plus r plus mu is equals to 0. So I think we can now, the middle term is the only one with I. So let's see, let's move it to the other side and bring all these ones. So I have beta pi minus mu
into
into
bracket.
brackets alpha
Yeah, plus alpha plus alpha.
plus r plus mu. Then mine is equals to, sorry, so the one with this guy will move now. So beta I into alpha
Alpha
plus
r
r
plus mu
plus mu. So I can divide both sides by what now to get my
by
I?
beta
Ma, please wait.
by
Please
beta
wait.
into brackets alpha
Please wait,
plus
ma.
Okay, they said we should wait though. Okay.
I understand every other thing, but I just want to ask, why is I squared now? Why is beta I squared now beta I in the next equation?
Okay. Look at the first one, beta pi I. There's I. Beta I squared times something. There's I.
Yes,
Mu high times something. There is high. If you look
yes.
at, thank God I've not erased it. This is the step. This is the step in which I have I. So I said factorize I out of the bracket. So by the time you factorize I out of the bracket, you will have I times something is equals to 0. So it is because we have removed I. That's why you will see that all of them, one i's have left them. Beta pi I is now beta pi. Beta I squared, one I has gone. I'm left with beta I. Mu I, the I has gone, one I has gone. So I'm left with mu. So what I have here at this point, it is that I cannot be 0, because the line I should have before this one should be I times this is equals to 0. But because I know that my I cannot be 0, it is this one that will now be 0. So you will now continue with the one that should be 0. Is that clear now?
Yes, ma.
Okay, so what we now did, the middle term is the only one that has I. We moved it to the other side, and now we are trying to make I the subject of formula. So beta pi minus mu. So we have alpha plus r plus mu, everything over beta into alpha plus r plus mu. So if you look at all these things, parameters, that's what we have. Values, beta is a value, mu is a value, pi is a value, alpha is a value, r is a value. So everything that we have, they are values. So one last thing to do, we will go and put this high inside our s.
Okay.
If you look at our s, you will see that there's I inside. So we go and put our I inside our s. So who is helping us with that?
Okay, so our S was originally pi divided by bi plus mu. So if we
Okay.
add the new formula for I is equal to b pi minus mu into brackets alpha plus r plus mu all divided by beta into brackets alpha plus r plus mu. So S will now be equal to pi divided by b into all the values of I.
Okay.
A pi minus mu alpha plus r plus mu divided by this one go long go b plus mu. So divided all the values of
Of our I now.
I. So now plus mu.
So I'm already saying beta beta.
Yes. So the beta outside is going to cancel the beta at the denominator. Then it's going to have S is equal to pi divided by, let's write everything out.
So at this
Okay.
point, I will try to write the denominator as a single fraction.
Yeah.
So
So because of that, the denominator, mu, we carry the denominator.
yes.
That's b pi minus mu alpha plus r plus mu. Then the one that is outside plus mu alpha plus r plus mu. So we have a negative and we have a positive.
Okay.
So they will cancel each other out. So we are left with b alpha. That's s is equal to s prime rather is equal to alpha. I mean pi divided by
It is S.
b.
Oh,
Oh
it is
sorry,
S. Oh. Don't confuse yourself.
it's
Yes.
s
So,
is
yes.
equal to pi divided by b pi divided by alpha plus r plus mu. So it's going to be pi divided by 1 divided by beta pi divided by plus r plus mu. So it's going to change sides, which is pi multiplied by alpha plus r plus mu divided by beta pi. The beta pi can cancel, I mean the pi, the beta pi and the pi can cancel each other. So we
Okay.
are left with alpha plus r plus mu divided by beta.
So our S is equals to alpha plus R plus mu over beta. So you see, this is the most complicated one they can ask, and that's what you have. Question might not even want to stress you this much. Every other one is not as difficult as this. So if you can solve this, then we are good to go with every other thing. So I hope now it's not it's not a problem. I hope now it's not a problem now. So you can get different equilibrium points for different model diagrams. I think in your past question you can just go and check. I think there's another model diagram there. This just leave this one of 4 parameters alone. So that you will not go and look. This something like this question too now. You can also attempt it. Just find disease free. Trivia will always be 0 0. Disease free. Set I to be 0. Find S. Endemic. Find S. Find I. Substitute and find your answer. That's the highest they can ask. All what will be changing is the parameters. All your alpha, beta, gamma, r, theta. That's just everything that will be changing, because they will not want to repeat the same parameters for you because of all those set of I will cram it. Let them not disturb. I will just cram it. So I mean, once they change the parameters, now imagine if you had crammed with beta and gamma, like the first one we did. Now this one, now you're now seeing mu and r. So even what you have crammed self will fly. So you have gotten the steps, you've gotten how to do it. So even if they change the parameters, you are still good to go. Basically, all you just have to do is to follow the steps. Once you substitute s, you see a fraction, delete the denominator by multiplying all the numerator by this, expand all brackets, collate all the ones that look alike, factorize anything that is factorizable, and just work towards getting your I. The issue is always getting high. So once you have that end goal in mind, that is I am looking for, so all I have to do is to keep clearing. I just keep clearing till my height is standing alone, till I have just one term that has I'm good to go. So with that, any model diagram that they give you, you can be sure
Thank you
it's not
very much,
something difficult. So this is past this is past 2 hours. I hope there are no more questions.
No, but ma, what about the Jacobian and the Eugen value? Jacobian, what do they call it again? Jacobian matrix, Eugen value, and poly something character. Poly,
And that's the last thing. Jacobian matrix, characteristic polynomial, hidden value. That's the last thing. So I don't know if you will speak with your you will speak with your guy again so that you will fix your time. That's the last thing, and then we should cover that in another class. We
but
should
the thing is
cover
that
that in another class. That's the last.
the exam is on Wednesday. Yes, that's why we are asking.
The
The
exam is
exam
when?
on Wednesday.
The exam the
Yes.
exam is on Wednesday. Ah, but this past question now, I didn't even see any question on, except where they asked for definitions. It's good you know it actually. I think except for question 4, where they said, with appropriate examples, differentiate between characteristic polynomial and Jacobian. I did see. It's just that I mean these lecturers are very, very unpredictable. If I reach your own turn now, go and see one question on find the stability of the system. It's not what should we do now? So all we have is just Monday self, because Tuesday you are already a day to the exam. Uh I don't know. Oga.
Okay, Esther, Abigail, and Co. So how was
Yes,
the
sir.
class?
Oh, sir, the class was
Awesome.
beautiful, wonderful.
Awesome. Ha.
Because I was also with you. She was teaching, although I was busy with my statistical work, but nonetheless, I'm still listening to one or two things that she's saying. So, maybe you are going to fix another class. Maybe you are going to fix another class. Maybe after, when is the this exam?
The exam is on Wednesday morning, and we also have community medicine on Wednesday afternoon.
Okay. So that means that, can you use the whole tomorrow to read for your community medicine after the 7 to 9 tomorrow?